So I'm David Brooker. I'm a Cloud Solutions Engineer with Grey Matter. And in this session, I'm going to give you a brief introduction to Azure, some of the benefits and features and things of it through this PowerPoint slides. And then we'll do a demo of the Azure portal, a little bit on resource groups and role-based access control. We'll deploy a web app with Visual Studio. And then we'll deploy an Azure Kubernetes cluster through the Cloud Shell. So first off, just to give you a sort of scale of the infrastructure involved with Azure. It consists of 2 million kilometers of inter-data center fiber. It's got a backbone speed of over 72 terabytes per second across 54 Azure regions and counting, across hundreds of data centers and literally millions of physical servers within those data centers. Also, you can see at the bottom as well, there's 4,500 peering locations for you to connect into that, 130 edge sites. So, despite all this fast, sprawling infrastructure, they've actually made quite a good commitment to sustainability. So since 2012, they've been carbon neutral. At 2018, the goal was to be 50% of their energy use from wind, solar and hydropower, 60% by 2020, and then long term they want to be 100%. Actually ahead of schedule on this, they managed to hit 60% sometime mid-2018. Okay, some of the features of it. Security, it's built in from the ground up. So there's a feature of it called Azure Security Center that's built into the portal, gives you a good central view of all your resources and can assess and report on some of the security features of that. The web apps parts of it can be secured by SSL certificates, and again, certificates and the bindings are all managed within the portal, easily accessible. And all of the backups and managed disks for your virtual machines are all stored encrypted at rest. For security-wise, the Azure AD groups and users can be used to assign people granular security access to the resources or subscription at various levels. We'll go into a lot more detail on that in future. And also the auditing for all actions in the portal is on by default. There's a lot of compliances with various security accreditations, such as STAR, HIPAA, ISO 27001 and more, which can be seen here. Obviously, it's just a flavor of them. There are a list as long as your arm of the accreditations, but they're all viewable online. Okay, another strong feature of Azure is the hybrid connectivity. So you can replicate your on-premise Active Directory up to Azure AD, take across all the users and groups. So say if you haven't set up sort of a second account for the same person online, it's all just tied in together. Any changes you make on your on-premise AD account will take effect on the Azure AD. And you can then leverage these for business-to-business and business-to-consumers identity solutions. You can also connect your on-premise physical network onto your Azure virtual network via either a VPN site-to-site, or you can use ExpressRoute, which is a dedicated lease line from your on-premise network up to Azure data centers. Once you've got this set up, you can also offload your SQL onto your Azure SQL. You can use things like StretchDB or always-on availability, replicate your SQL server up to Azure, get hybrid use that way. It says high availability and disaster recovery. You're able to replicate your web apps and virtual machines and SQL. So this can improve your availability and speed, and also when you have your SQL servers on Azure, there is at a minimum 7 days worth of backups, configurable up to 35 days, so you can retain any point in that time. If that's not enough for you, there's also the Azure Backup, which can back up your resources within Azure as well as your on-premise resources. And for the disaster recovery, we can use Azure Site Recovery. So we can replicate your resources, again, from either on-premise or in Azure. And then should they ever, in the event of a disaster, we can use those replicas to spin up new compute units, and you can switch over and use those within 2 hours. Scaling is another option with a lot of the resources in Azure, including VMs, web apps, and SQL. So you can scale out your web app automatically based on either rules or a schedule. So you can set a monitor. If your CPU usage for a web app, say, ever reaches 70% or more for 10 minutes, you'll automatically scale to an additional instance to meet the demand of your customers. And to reduce costs, you can set another rule. Perhaps say next time the usage drops below 15%, you can scale that back in, drop back down to one less instance. Save money that way. There's a very similar mechanism available for SQL databases. Also able to scale that out globally to different regions and allow your users to use the most local resource to them to reduce latency there. And then when you scale, load balancing is built in automatically. So as soon as you have more than one instance of a web app or VM or anything, there's automatically going to be load balance so that they're receiving equal traffic managed between there and also globally. So user on one side of the world is going to get a different instance. The user on another side of the world, they're going to get most local to provide low latency and high availability there. Also, in a similar way, you're able to take pressure off your primary database. You can send read workloads, like reporting, for example, over to another read-only geo-replicated SQL. To support all this, Microsoft has financially backed SLAs. See some of them there. There's a lot of resources will even offer higher those if you employ some of the high availability options, like scale sets and availability sets. I think it even goes up to 99.169s of SLA there. As well as this, if you do need support, if you join on with Grey Matter as a CSP, we can provide 9 to 5 free support included in that. If there is something we need to bring in Microsoft for, we can escalate that to you on your escalate to them on your behalf. And we've also invested in the advanced support for partners, which allows us additional resources and Microsoft support. I've got a proven track record. Over 80% of Fortune 500 actually uses Microsoft Cloud, which culminates in 12 billion plus weekly AD authentications. And to be honest, this is a little bit out of date, so I imagine that's gone even more. Once you're on the portal, a lot of the tools available to you are going to be very familiar, very similar to the ones you've already used, such as PowerShell, SQL Management Studio, Visual Studio. Those can all tie in with the Azure resources, so you won't even have to interact with the portal and learn anything new with that. You can carry on using a lot of the similar technologies you're used to. There's a lot of open platforms available, .NET, Java, PHP, all things you're going to be familiar with, as well as a whole host of others. And it all means it's just going to support a seamless development, online or offline. Wherever you are, you're able just to carry on as you were, but instead all of your management side of things is going to be handled in Azure. So I won't spend too long on this because there's quite a lot going on here. This is just a quick overview of, even this isn't all of them, but some of the services available on Azure. See they're grouped. We've got a lot of the platform services at the top here, infrastructure services. So there's the Azure Site Recovery I mentioned, example, scale sets. Like I say, there's this. We could spend hours going through all that, so we'll just go ahead. So what do I mean by platform services and infrastructure as a service? So this is what's called the shared responsibility model. If you're on-premise, the entire stack is your responsibility. So right down from the physical bit of tin in your server room, all the way up to the application, you're going to be responsible for anything that happens anywhere in that stack. Move on to Azure and employ some of the infrastructure as a service, you're only going to be responsible for the OS layer up. So all the physical servers that it runs on, the hosts, the hypervisors, all of that is handled for you by Azure. If we move even further to the right, employ platform services, we're only going to be responsible for the data and the applications. You don't have to worry about the operating system, anything in between there, it's all going to be handled for you. And then even further to the right, software as a service, these are things like Office 365, you just log in and use, there's no management really there at all. So, what do you get from moving to infrastructure as a service? You're going to eliminate capital expenditure. You're not going to be buying costly servers and upgrading those with hardware refreshes. You're going to have your ongoing costs for your usage. You're going to be a lot more flexible in this. You're going to be a much more business continuity disaster recovery available to you with a lot of the Azure services. It's going to allow you to deploy a lot more quickly and also scale to meet demand much more quickly. And all of this is going to result in increased stability, reliability, and supportability. So this is just a quick view of what it might look like employing some of those Azure resources to build an infrastructure as a service application. So we've got the Azure Load Balancer, sat in front of the availability set of VMs. So what an availability set means is there will always be at least one of these VMs powered on. Come rain or shine or update or disaster, at least one of those will stay up. They're going to be passing the data then to another load balancer. Similar setup here to the business tier, and then the data tier with a couple SQL servers. So all this is hosted within a resource group in a virtual network. If we want to make that multi-region, it's very much similar fare. We just take that, copy it, and create another one in another region. VPN gateway between the two allows the SQL servers to replicate, and we just front it all with the traffic manager. So wherever the user is connecting from, that traffic manager is going to intelligently decide where to send that traffic. But platform services, if we move to there from infrastructure, we're going to get a reduction in cost and management, because as we say, we move further to the right on that shared responsibility model. We're not responsible for any of the OS level below, or above, sorry, up to data. So it's going to result in improved scalability, because there's less moving parts there. It's managed by Azure. Simpler architecture, which is all going to result in increased time to market. So we have a quick look at how that's going to look. So at first glance, it might look as complex, but there's actually a lot less moving parts here. So we've got our user authenticating via AD into our app service. There's going to be the instances here we spoke about scaling. Below that, we've got where our developers are going to deploy to. There's deployment slots, which we'll cover in the demo with Visual Studio. Got Azure SQL database holding our data, and then storage account just holding some logs and things we might need to look at later on. So all this is in a resource group, but you'll notice there's no virtual network. We don't need to worry about any sort of traditional network infrastructure, no kind of architecture there. It's just the services talk to each other, which again is just going to lower management. And then if we want to take it multi-region, again, similar kind of thing, just going to replicate that to another region, front it all with the traffic manager. But again, as you see, we've got no virtual network. There's no need to set up any sort of gateway or any complication there. Right, so if we move on to the demos. So this is the Azure portal. This is the dashboard. It's what you're going to be met with when you log in. So straight away, we've got sort of a fairly good overview of what's going on here. We can add additional parts to the dashboard, perhaps. Oh, no, sorry, that's no, we don't. Yeah, we'll add things later on there. So I spoke about resource groups and deploying to that. So resource groups, just sort of a logical container for your resources, so you can group things together that are all similar. So say we've got the VM, we've got all the moving parts for the VM held within this resource group. If I just show you, so it's just as simple as stick that on our subscription, the resource group and name. What we can do is add tags. So for the purpose of perhaps billing or things, so you can keep things grouped and understand what everything's being used for, give an environment, tag and value. Create that. Give that a refresh. There you go, we got this here. So we've got our tags. We can see that at the end of the month, we can sort our billing and sort it based on tags, and it just gives us another layer of structure there in management. Now the role-based access control I spoke about before. At the minute, this is just my subscription, so it's only myself that has access to it. What I can do, so for this resource group, I can add a role assignment. So I may want to collaborate with a colleague. So this is all pulled from Azure AD, which is synced from our on-premise. So add my colleague in there, and you'll see there is a huge list of different roles we can work with here. So these will all have varying permissions. If you hover over the eye, it gives you a bit more information there. And if for some reason there wasn't a role in here that suited what you wanted to do, you can actually create as well your own custom roles. But we'll give Dan contributor, so that is going to allow him to use any of the resources in here, manage them. He'll be able to do basically everything except give other people access. So just hit save. And there we go. He's shown up here. So now anything within this resource group he'd have full access to manage, but he would not have access to anything above that in any of the other resource groups. And if we wanted to give him access to a single resource, it would be a very similar process to click in the resource instead of the actual resource group. And then there's a very similar portal here with access management. Okay, so you'll notice on resource groups and resources have very similar few options here at the top. So these are fairly universal to all the resources in Azure. There's an overview tab. It just gives you at a glance information about this resource we're looking at. So since this is a VM, got things relevant to this VM, we've got the resource group that it's in. We can see it's currently stopped. We can see the computer name if it was started, the operating system it's on, the size, so there's all the resources available to it, how much oomph it has. We've got the public IP address that's been assigned to it and the private IP. I say, whatever resource you're looking at, these are going to be sort of out-glance information you might need to know. We've got activity log. So yeah, this has been on for the last 6 hours, so not much there, but if we up that to a week, you can say there's a log of anything happening here. So this is what I was speaking about earlier with the auditing being enabled by default. So we can scroll through that, see what's happened. Perhaps we've seen that it was restarted, and in future we'd like to be alerted about that. If we just click on the alert, and we can create an alert rule. So it's already filled in for VM01. The condition is whenever there's a restart machine, and we can create what's called an action group. So this is going to be the group of people to be alerted when this happens. Give it a name. We give it a short name. So this is if you're by SMS, you can shorten this to abbreviate it. And the resource group to create it in. So we can either create a default, create a new one for all activity log alerts, but maybe I want to keep this grouped up with the VM that it applies to, and then action name. So we'll call this email. Got a host of ones here, so I don't know if you can see that back. It says email, SMS, push, or voice, Azure function, logic app, webhook, ITSM, and automation runbook. So you can do a lot of clever things here. If you've got an external help desk system, perhaps you can create a webhook here so that when the alert fires, it'll actually create a ticket automatically in that, as well as it'll email your engineers and allow them to know it's happened. So we should do a nice simple email one. Cool. And then that's that action group created. You can see that's added in there. So that was just a single user myself, added it in there. Perhaps you've got a whole team of engineers that you're going to get these alerts to. Rather than having to fill that out each time, that's created an action group now. So I can just select that again if I ever wanted to apply it somewhere else, so you're not putting in the same information. Cool. Well, then of course, sorry, give the alert a name. Fill in the description if you want, and then create alert rule. Cool. So I would have gotten an email about that as well to say I was added to the action group, so everyone that's getting an alert is going to know about it beforehand before they just suddenly start getting alerts. And then of course every time the alert fires, they'll be given an email. Another fairly universal one here, we've got the metrics. So again, this is a virtual machine, so these metrics available here are going to be different to other resources, but fairly common one, perhaps percentage CPU. And again, it's been off for a while, so, but it would be there. And if we wanted to pin it to the dashboard, so we had that visible straight away, simple as that. And then as soon as I log into my dashboard, I'm going to be able to see CPU percentage of VM. So if you've got quite a critical, mission critical resource you want to see straight away, you're going to get a view of it straight away as soon as you log into Azure. Cool, so if we move on to the deploying a web app. So perhaps you're just a developer, you don't want to deal with Azure, that's not your bag. Going to use Visual Studio, which you'll be familiar with. Going to create just a basic web application. Give it a name. This is going to be creating a repo on our laptop here. Great. So we've got all the usual bits, just a default index page. So at the moment, this is all just locally on our laptop. If we right click here and publish, what we can do is create a new Azure app service. Right, I'm already logged in, so it's just going to connect straight away, but if you weren't, there would just be a little login prompt here. So we're going to give that web app a name. Let's keep it nice and simple and take the numbers out. Going to put the subscription that we want to charge it to. A resource group, what I'm going to do is create a new one. So we'll call this ISV Partner Day. And a hosting plan. So what this is sort of the physical resources allocated to your web app. So a single app service plan can host a number of web apps. And depending, obviously, how much resources those web apps need, you may want to put less or more on a single app service plan, or scale maybe a higher service plan for certain web apps. And we're going to pop that in UK South so it's as local as it can be. Again, we'll just keep things simple. So ISV Partner Day Web App Plan. Great, there's application insights available as well. It's going to give us more information and recommendations on performance, but since this is a demo app that I'm probably going to delete in half an hour, we'll just leave as is. Cool, so I've hit create. What that's doing now, it's going to go connect to my Azure app subscription. It's going to create a resource group called ISV Partner Day. In that resource group, it's going to deploy a hosting plan at S1. And then in that hosting plan, it's going to deploy a web app. And then it's going to push all this code straight up to Azure. So if we have a look in the portal while we're waiting for that, we should see things starting to come to life. So here we go, we've got ISV Partner Day. It's been created. We've got our app plan. Let's see how we're getting along here. Still deploying. Cool. That looks like the web app's deployed. So while this is pushing all our information and code up to the web app, if we just refresh this. Yeah, there we go. We've got our app servers as well now. Flip back to Visual Studio. So here we go. It's just deploying all our code up to Azure. So again, if you were just a developer, you don't want to deal with Azure Portal. At this point, you never really needed to flick back to the portal. That was just so we could keep an eye on things. You can just do this all through Visual Studio. And that is starting to launch. I am beholden to the free Wi-Fi available here, so bear with me. There we go. Great, so there we go. It's come from our laptop that is now hosted in an Azure data center. You'll see at the top here, it is our web app name, .azurewebsites.net. And that's all obviously certificate and everything coming from Microsoft. You can click about, all that good stuff. But obviously when you host a web app, you're not going to want .azurewebsites.net. So if we go to the portal, click on our web app, and then, like I say, a lot of these options are going to change resource to resource. For the web app, we've got a custom domain one. So it's as simple as add host name, stick in a domain, obviously that you own. That's going to validate it, and once it checks that it's not used for another Azure resource, it's going to give us some DNS things to put in. And obviously we're on a bit of a time limit here, so I'm not going to have a chance to validate this and get it up, but it would be just a case of adding those records, hit validate again, and then I'd be able to add the host name, and then from then on I'll be able to access that web app from my own custom host name.
Can you restrict who can view that web app? So can I release that to a team of developers from an AD group, for instance?
Yes, you can. I'll tell you what, I have timed this before, so it's in, but if you catch up with me afterwards, I can go through that. But yes, you can restrict it by IP and things as well, and authentication. So we've got a custom domain. We want to add certificate. Just in case, you can upload your certificate here, and then create a binding. So we'd have our host name, ideally, if we'd validated that. Choose our certificate, and then just add binding. Try not to click off your web app. Great. So just quickly on authentication actually. So we can actually leverage some built-in authentication here. So we can use Azure Active Directory Microsoft accounts, Facebook accounts, Google accounts, and Twitter accounts. So you won't need to develop any of that yourself. It can all be handled by Azure, so you can limit who can access your app, or perhaps you can allow them the option to log in and then collect that information. But again, that's a bit beyond the scope of an intro, so we won't go too much into that, but just know that it's an option. Of course, there's a configuration here as well. So if you, this is a very simple web app, so it doesn't have one, but if you were to have a, I assume you probably would have a database attached to yours, add the connection string here. And there's a check slot here for slot setting. So we'll come onto that with deployment slots, but you can keep the connection string constant to your production deployment slot. So your development slot can point to another sort of dummy dev database, so you're not going to accidentally fill your production database with a bunch of test data. Cool. So we've got a web app up, we've got a host name, it's secured, we're getting somewhere. Of course, backups are important, and it is a very quick to configure with web apps. It's just a case of click backup, configure that. Choose a storage account. There's another Azure resource available to us. Perhaps we've not set one up yet. It's just a case of hit storage account, give it a unique name. So this does need to be completely unique because it's just given a web address, .core.windows.net. If we choose IC Partner Day 16.4. Cool. Again, put that in a more local region to us to improve the latency. Yeah, okay, right, so that's going to start deploying. It can take up to about 5 minutes. So in true Blue Peter fashion, here is a storage account I created earlier. Create a new container for your backup. So within the storage account, blob storage, there's several containers. You can split this up. So if we create one called backup, has to be all lowercase, no spaces, and then there might be instances perhaps you'll want your blobs available externally, so you can change that there, but obviously for backups we're going to keep that private. Select that. Cool, then we just turn on scheduled backups. So you can back up every day, every hour. You can choose perhaps when you want it to start from, and then a retention of how many you're going to keep. So you just leave those at their defaults. You can also add the database. As I say, we don't have one, but if we did, we could include that in the backup. Hit save. There we go, and that's going to straight away start creating a backup of our database, our web app, sorry. So now we've got that secured, we're happy with that. It's getting popular, and it's starting to get hammered. We need to scale up to meet the demand. So this is the auto scaling I was speaking about earlier. Enable auto scale. Give it a name. If you've got quite a complex web app and different scales up and schedules down and things you want to build, you might need to give it different names, but we'll just create a single one, which call it auto scale. So we're going to add a rule. So it's going to scale based on a metric. When the CPU percentage is greater than 70 for at least 10 minutes, it's going to increase the count by 1 and then have a cooldown of 5 minutes. So if after 5 minutes it's still at 70, it'll add another. Although we've given it a maximum of 2, so it won't. We'll say 5. And then, of course, got to keep costs down. So I'll add another rule. When the CPU percentage is less than a number, we'll say 15, for 10 minutes, instead of increasing, we're going to decrease count by. And then again, similar cooldown, 5 minutes. And then we've got our minimums. There's always going to be at least one instance. Obviously, there's going to be a maximum of 5. And at default, we're going to start with 1. Hit save. That's going to apply those auto scale settings, and then straight away we've got a scalable web app that's going to meet demand and also scale back to save costs when it's not in use. And if you knew perhaps your web app's going to get more traffic on the weekend, you want to scale up preemptively, you can also set to a specific instance count and do it on specific days. So as I say, it's always high on the weekend, 6 AM till 6 PM on Saturday, Sunday. We can scale this up to immediately be 3, and then the other rules can kick into effect if needed. Or perhaps there's an event coming up, we can just set a start date for a one-off. Cool, so I'll discard those few changes there. Logs. always important. We can grab those here. Again, I am beholden to open Wi-Fi, so we'll just, there we go. Right, so we can turn on logging here. We can choose application logging and go to the file system from the web app, or we can use that blob account again. So we set the error level we're interested in, choose our storage account again. We'll create a separate container this time for logs. Again, private. Choose that. And again, choose retention. So we'll say 7 days, for example. And then also there's a few other logging options here. Web server, request tracking, and then we can also download those via the FTP. Save that. Straight away, we're going to start collecting logs that we can access and review as needed. So we've got our web app up. It's successful. Everyone loves our incredibly standard web page for some reason, but we want to improve on that. So we can create another deployment slot. So in a slot, we'll give it a name. Let's call it dev. So we can clone, if we were to have set anything here specific in the configuration settings, we could clone that from the slot. Let's say we left it standard, so we'll just leave that. It's going to deploy a second deployment slot. So this is almost like another web app below this web app. So once it appears in this list here, we'll be able to click on it and we'll have all those same options on the left, but it's essentially a different web app. So any changes we make there aren't going to affect our production one. Cool, so we got that. So you can see we called it dev, it's just going to append -dev at the end there. But again, developers don't want to deal with Azure Portal. They want to stay in Visual Studio, and that is absolutely fine. Create an index page. I'm not going to make you suffer through me trying to type that all out correctly, so I've got a handy notepad file there. There we go, that is a massively improved web app. So we're just going to publish that again, but rather than going straight to production, create a new profile. Now this app service already exists, so we're going to click select existing. It's going to find our subscription. We're going to browse by resource group, and there we go, we got it. And then below that, we've got a deployment slot and dev. Okay, straight away that's going to start deploying. So like I say, this is it's not going to touch our production one. It's going to be a totally separate web app slot called dev, and it's going to publish it to there instead. And similarly, while that's pushing up code, once it's done, there we go, it's going to launch. So you'll notice the URL there's changed, and it's just appended -dev.azure websites. We got a different app. Just to prove, exactly the same address. And again, as you asked earlier, you could lock this down, so it's only accessible perhaps by your office. So perhaps you want to test with that. We want to use a small sample base. We can actually change the traffic percentage here. So if we put 10%, that means 10% of all requests are actually going to go to this dev slot. They can try it out, and 90% are going to carry on going to the production. What that does is add a little cookie, so there's actually a mechanism you could do so people could opt out if they don't want to use the dev slot. They're not like in the new updates or something. You can always give them the option and it will change that cookie back so they go into the production site. But we've tested it, we're confident, we're ready to put that in production. So what we can do is just hit swap. So the source is this dev slot. So if you had a few slots, you could have perhaps staging or perhaps different stages of dev. You'd have a few more options here, but we've just got our one development slot, and that's going to push the code to the production slot. If we had some more configurations, they will be listed there, so you get a glance, you can see what's going to change there. And if you remember, I spoke about connection strings and sticking to slots. So this is where you'd have the, it would show you that the connection string was about to change. But without further ado, I hit swap. And that's going to start pushing from our dev to production and vice versa. So what was in the production slot will end up in dev. If there were any unforeseen changes, perhaps your users are better at breaking things than you had predicted, you can hit swap it straight back. There's going to be minimal downtime. You can get back to your working production website and trying to work out what went wrong on dev. You see, even during all that process, oh, there we go, it swapped already. There was a very minimal downtime. There'll be seconds, perhaps, if not even that, where it's in the process. But the production site will always stay up, and then this will take a little longer, but as it's dev, there we go. So we've just swapped totally from start to slot with minimal downtime. And this is still catching up to itself, but as you've seen, proof's there, that's swapped. Cool, right, I will move very quickly on now to the Kubernetes demo. I'm very conscious of time. So there we go, just showing successfully completed. Okay, so for this bit, I'm actually going to use a feature called Cloud Shell, and we will just pop that out to a new tab of its own. So this is either Powershell or something called the Azure CLI, which if you're familiar with Bash, it's going to look very similar set of commands, and this will interact directly with your Azure subscription or tenant if you have several subscriptions, and allow you to use command line to manage your resources as well. So again, I won't make you suffer me trying to type commands wrong under pressure. I'm going to paste this command here. What this is going to do is create a resource group called ISV AKS, location city AK South. Very quick command. You can see the output there, just showing you that's completed correctly. And so this next one is going to create a Kubernetes cluster. So again, I don't know if anyone's familiar with Kubernetes here. Has anyone used it? Yeah, I see a few hands going up. Yeah, so it's an orchestration method for containers. It's not brilliantly easy to set up, but on Azure, fortunately, a lot of the management is handled for you. If you are unfamiliar with it, there is actually a brilliant, if you search for designing distributed systems, this is available to download from Microsoft. It's, I can't remember, I think like 300 or so pages, so it's not a light read. However, if you want a slightly lighter read, there it is, and someone's already seen it. Fippy Goes to the Zoo, which I would love to have the time to sit through, maybe do funny voices and things, but it's just all the elements of Kubernetes in a very easy to digest way. I was actually going through this last night. My wife looked over my shoulder like, what? I thought you were doing a demo. What are you? Great, cool. So there we go. There's our cluster already deployed all for us. Sorry, I should have gone through that command in a bit more detail there. So this is just very basic settings, just giving the resource group we're creating it in, the name of the cluster. We're just putting a single node here. We're going to enable monitoring. And now that's done, I'm going to grab the credentials for that cluster and pass it to our session. And then just check we've got that. We're going to get a list of the nodes that are currently running. Cool. And some of you with good eyesight from the back there may notice the age actually says 4 hours. So I've told a little white lie there. We didn't deploy it. We actually just verified it, because deploying it does take up to 15 minutes. And I am not charismatic enough to keep your attention for that long without anything going on. So for the benefit, but all this now is live. So we've got our nodes there. We've seen that's up. What we're going to do is create a simple app. Take that code. And we're going to create a YAML file from this. Azure vote.yaml. See that there? And then we're just going to deploy this to our cluster. Right, and well, it'll take a little while to deploy, so what we'll do, we'll just watch the service to see when it comes up. So you'll see the cluster IP is already provisioned there. We've got that. But the external IP for this application is still pending. So sometime, hopefully very shortly, that will pop up. We'll be able to have a look at the web app. But I mean, once that's done, that is a web app, an application produced to Kubernetes, which can be quite a lengthy process, but with Azure, a lot of the management is handled for you. So it's very easy to deploy. Should you need to update it, again, if you're managing this yourself, you've got several virtual machines set up for this, holding the cluster information and orchestration. It can be a pain to get all the nodes updated to the same level and your containers moved around. But for, where is it? It's in here? No, I've clicked the wrong one. Bear with me, sorry. It's here, isn't it? Yeah, it is. So our AKS cluster, this is a resource that is represented in Azure. To upgrade this one to a new version, it is almost uneventfully easy. You just choose the next one, hit save, and then that will automatically move your containers across to a different node, update that node, move it back, so without any downtime, it manages it all for you. As well, the underlying VMs that this all runs on, you benefit from the built-in security of Azure. So all of that is already security hardened, updated to best practice. It's totally out of your hands. That's dealt with by Azure, so that's one less thing to worry about as well. Developers can get on with developing and not supporting infrastructure. And then, of course, the other strong benefit is the cost. Because you're not managing these VMs, they're not in your realm, you're not paying for them either. The management plane is handled by Azure. You're just paying for the nodes that you're running on.
That's a very good question there. You're updating the Kubernetes version there.
Yeah.
What about updating your containers?
If you catch up with me afterwards, we'll go into that, because it's, again, I'm very conscious that I think I've actually run out of time, but I just want to quickly get through this. So, cool. So that's updated. So hopefully this has had time to provision. Sometimes it does take a little while just to fully process through. And if so, again, putting on my blue hat, Peter hat, I provisioned this morning before I left. So this is what the app would look like. So there we go. It's just available via external URL. If any of you wanted to go to that, you could go as well. And then very simple app. There's not much to it. I'm not a developer, so you have to be a bit more creative yourselves. But there we go. That's been deployed on a Kubernetes cluster. Like I say, I did that one this morning before I left. But yeah, this one's still in the process of provisioning. But that's it. I think that's what we've got time for. But I say, unfortunately, the session has ended its lunch now. But if you have any questions, by all means, come up or catch me the rest of the day. Thanks very much.